Hey guys, and welcome back to a new video. In this video, I will go through the gazillion different ways we have in Android to share data between different screens. I see many people actually have this very common problem. This is something you want to do in pretty much any app, that you need to share some kind of data between at least two screens. And since there are just so many different ways to do that, which all have their advantages and disadvantages, I will now go through all of them and highlight, what is good about them, what is not so good about them, and in which specific scenario you should use which way of sharing data. You'll also find jump marks down below, so if you already know some of these ways or you already know the advantages and disadvantages, then you can also skip specific sections to jump to the next ways. And also I think it's worth mentioning that there are some ways I will leave out here which rather refer to the old approach of building Android apps with XML and activities and fragments. So there are some ways which I will leave out here because from this point on I consider my channel Compose only, and in this video I will also only show you ways for Compose projects. And just to quickly mention all the ways I will go through here, that is first of all navigation arguments, second is using a shared view model, and I will also show you code examples. You will find the code down below, so you can also play around with these. The third way will be sharing a stateful dependency. Way number 4 will be using the composition local of Jetpack Compose, and way number 5 will be using persistent storage. And all these ways except for one have a use case, so it definitely makes sense to understand in which case you need to use which way to share data. So let's jump into it and start with the most simple way, which most of you will probably already know, and that is sharing data using navigation arguments. So here I've set up a very simple example of that, where we just have a nav host in Compose, in which we can then assign or set these composable blocks, where each represents a single screen. So here we want to be able to navigate from screen 1 to our screen 2, which is in here, and we want to share data between these two screens. So we have some piece of data on screen 1, and we want to have that same piece of data on screen 2. So what we can do is we can simply pass that as a navigation argument, which I'm doing exactly right here. So for our screen 2 in this case, we would need to specify, hey, we want to be able to receive this specific navigation argument. In this case, I just call it my param. And then we specify here in this list that we have this nav argument, which is called my param, and it's simply a string. And then when we navigate to the screen, we can retrieve this parameter using that argument. So we use the nav backstack entry, which is attached here, and we simply get this string with this specific key. And we can then simply pass it to our screen and display it on the in a text or so, whatever kind of argument that is. So here, when we navigate to our second screen, we simply attach this to the route in the same format we specify the route here in. So in this specific example, if we take a look at our very, very simple screen 1, if we click this button, we navigate to the screen 2, and the navigation argument is simply the string hello world, which we then want to display in a text composable here on screen 2. And that is exactly what happens if we take a look at this example, if we execute it. If we click me, so currently screen 1, if we click me, we pass this argument to the screen 2, and we display it here on screen 2. So we effectively share data between these screens. So while this is a very common way of sharing data, I think only few people know about its advantages and disadvantages. One advantage, which might be rather obvious, is of course that it's pretty easy and straightforward. There's not a lot of restructuring needed if you want to simply pass a value to another screen. Another advantage is that these values, so the data that we share here, survive process death by default. So for those of you who might not be familiar with the concept of process death, which I will go through multiple times in this video, that basically means if your app is in the background and the Android operating system is very hungry for memory, it might decide to kill your app, which we can simulate in Android Studio going to Logcat and clicking this little red terminate application button. If you're using the newer Android Studio versions, you need to explicitly enable this in the settings, but that basically simulates this process death behavior. So if we click that, go back here, then what you will notice is if we go to the recently used apps tab, then our app is still active here, even though we click terminate. And process death in Android behaves the same way, because what Android will do if the user goes back to this app, Android will restore the backstack, so it will send the user to the previously used screen. However, since the process effectively died, that means the whole application state also died, meaning all the states in the view model, all the states in the screens, unless you put something in saved state handle, which will survive process death. And these navigation arguments are put in this saved state handle, which is why they will survive that. So if we go back, then you will see that even though the app is actually relaunched, we still see the value hello world, which was the navigation argument here. And since not all the ways I will show you survive process death by default, I think it's worth mentioning that explicitly. But now let's get to the disadvantages of using navigation arguments. And that is, on the one hand, that it's simply not well suited to share complex data. Especially in Compose, it's not possible by default to share something like a parseable, and especially not something that can't even be put in a parseable. And also disadvantage is that it's not very convenient to share data between multiple or many different screens using navigation argument. Because let's say you need this hello world string not at this screen 2, but at screen 7, for example, then you would need to pass it from screen 1 to screen 2 to screen 3 and so on until you reach screen 7. So that's not very well suited. And of course, this data we pass here is stateless. So this value will not change after we pass it. So if this hello world string would be some kind of dynamic string which changes over time, then we can't use navigation arguments. So what do we learn from that? Use navigation arguments if you need to pass stateless data from one screen to another, but not if you need that data in a lot of screens. Coming to the next way of sharing data, which is a very popular one, and that is using a shared view model. So usually in Android, a view model is bound to a single screen, and that means the view model will die as soon as this screen is popped from the backstack. But what we can do is we can share a view model between different screens so that it's not popped when one screen disappears from the backstack, but in some other kind of condition. And all of the screens will then be able to refer to the exact same view model instance and access its state. And the very cool thing is that we can scope these shared view models to a part of a navigation graph, so to a subgraph in the end. And that is exactly what I did here in this little sample. So here we have our nav host again, just as we had before, but then we have this navigation block instead of having these composables right away. What this navigation block will do is it will create a nested navigation graph. So instead of our big graph here, we will have different subgraphs. And each subgraph is in the end just a set of screens that belongs together. So here, for example, we have an onboarding feature kind of, and in this onboarding feature, we just have multiple screens. Here, for example, for the user to enter their personal details and then to see some kind of terms and conditions. And after that, we consider the onboarding done. And these personal details and terms and conditions belong together, and you can only get to the terms and conditions by first filling out your personal details. So this would be a brilliant example of using a shared view model, which I do exactly here. So we can refer to this with entry shared view model, which is a custom function I created here, and then just observe the state totally normally as you would with a normal view model, which is bound to a single screen, and then just pass that to all your screens. Here we have the exact same thing. This is the same instance of a view model than it is here. And because of that, we also get the same state on the other screen, which you can also pass in here. Let's take a quick look into this shared view model function. So how we can retrieve that in a nested navigation graph, which is right here. Looks very complex here, but in the end, this is just so that this works with any type of view model instance and not only with our specific shared view model here. And then all we really need to do is we need to get the nav graph route, which is the route that refers to the start of our nested navigation graph, in this case onboarding. So if we navigate to onboarding, we directly get to the first screen of onboarding, which is the personal details screen. So we first of all find that route, and then we have a remember block where we pass this as a key, so the nav backstack entry. So whenever this changes, we just re-execute this, and we get the backstack entry using our nav controller by passing the nav graph route. So effectively, we just get the backstack entry of our nested navigation graph, and we can then use that to simply scope our view model to this parent backstack entry, so to the backstack entry of the nested navigation graph. And what that means is that the view model won't be cleared if a single screen of the subgraph is cleared, but if the whole subgraph is cleared. So for example, if the user finished onboarding and you get to the next feature, and then you pop the whole subgraph from the backstack, which we do here, for example. So we say nav control and navigate to some other kind of screen, and we say we want to pop this up to the onboarding feature, and that is inclusive. So we also pop this feature. And if we take a look in the shared view model, that is a very, very simple sample view model here. The shared state is just an integer. And if we call update state, we just increase that by 1. So I can show you that this works. And we also have a println statement when the view model is cleared. So we can actually check this behavior that it's really bound to the navigation graph. We call this update state function in our onNavigate function. So right before we navigate, we increase the value from 0 to 1. So the next screen where we display this the terms and conditions screen, the text on the button should simply show state 1 because we increased the shared state. If we launch this and try this out and also take a look in logcat, search for, what was it, ViewModel cleared, and take a look here in the app, then we again can click on click me, where the state is currently 0 on the screen. If we click me, we increase it by 1, the shared state, and we see it's now at 1 on the next screen. We don't see a log here that the ViewModel was cleared, also because we didn't pop anything from the backstack. But if we do pop something from the backstack, which is now the second screen, then also the ViewModel won't be cleared because it's bound to the whole nested graph. And we can do the same thing now over and over again. We can click me, and now the state is 2 because we again increased it. So it's a shared state effectively. But as soon as we click on this button and clear the whole graph from the backstack, then you will see the ViewModel was now cleared and the state will also be reset therefore. So in which scenarios should you now use that? Let's go through the advantages and disadvantages. A big plus is of course that it can easily be scoped to a navigation graph, which I just showed here. You can of course also share a ViewModel by binding it to your activity, but in a Compose project that usually just refers to making your ViewModel a singleton, since you will only have a single activity. So if you have, let's say, 7 onboarding screens, then this is now much more convenient than navigation arguments, because you just need to add all the data the user already entered to the shared ViewModel, which all screens have access to. And what about process death? So what happens if our application dies, as I just showed for the navigation argument sample? Will this state here also survive process death? Well, not by default, but if we have state in the ViewModel, we can easily restore that from process death by injecting the save state handle here. So simply save state handle, and this is where we can put the state after, or we can save the state after we change it, and then also where we can retrieve it from when we get back after process death. But I have a dedicated video on that on my channel. And by the way, of course, if you're using Hild, then you would need to change this approach a little bit. Then you would need to swap this out with Hild ViewModel. So you actually inject dependencies in your ViewModel. And another advantage of this approach is that it of course supports real state changes. So in contrast to the navigation arguments where you just pass a one-time value, here you can actually change the state. And it can also be any complex value, even if you can't put it in a parcelable, since you can put anything in a stateful. So does this approach have a disadvantage? Yes, I see one, and that is that it can become a little bit difficult to maintain and debug specific components if they are all coupled to one shared ViewModel. And that is especially the case if you have a state that is screen specific. So let's again take the example of 7 onboarding screens. And if you have a state that is only specific to, let's say, onboarding screen 2, and you have shared state, because then you effectively need 2 ViewModels, unless you want to put it all in one shared ViewModel, where you will have data that is not needed by all these screens, or by multiple screens at least. So this does create a little bit of coupling and can make it a bit harder to understand where data comes from, where data changes, and these kinds of things. So I personally like shared ViewModels if you have some subgraph of your application where each screen just adds a little bit of extra data which you need at the very end. Or for example, if you have one feature where the user just spends all their time, for example, let's say you have a video calling app where the video calling feature is only active when the user is actually having a video call, and then you have a chat maybe where you need to share data with the video calling feature. And if all that just needs to interact with each other in a shared or in a bigger feature, then shared ViewModels definitely do make sense. Coming to way number 3 to share data between different screens, and that is sharing a stateful dependency. For example, a singleton. So in here I have a very similar setup as we had in the first example, so just 2 screens, and we want to share this count value. So we just have one separate class which contains this count state where we can simply count up, and we want to share this counter value between different screens. And what we can now do is we can use a separate class which represents the global counter. We make that a singleton, for example, using Dagger Hild. And here we now have this mutable state flow. And since that's a singleton, it will simply just live as long as our application does. And we can then use the same global counter instance and inject it in both our different ViewModels. So you can see here in both these constructors, I inject this global counter instance. Since it's a singleton, it will be the same instance having the same state on these 2 screens. And here in our sample, if we click on the first button before navigating, we just increase the count, which is very similar to, I think, the previous example I showed. So if we try this out right here, take a look on the emulator, then count on screen 1 is 0. I click that, count on screen 2 is 1. if we now go back, you can see it also updates here. So we effectively share this count between these two screens. And the advantage of this is, of course, that it's pretty easy to just use this global counter instance and inject it wherever you need. However, I totally recommend you to not do this at all in any scenario. And the reason is that in Android, such global state, so state inside of a singleton, is very dangerous. You could theoretically also scope this to a navigation graph again by making this the view model scoped and then injecting that in a shared view model, but then you again have the same scenario as I previously mentioned. I just see many people try to be convenient and just make everything shared as singleton, and I want to make it clear that this is dangerous. And the reason is that with this global counter instance, you on the one hand aren't able to easily support process death, because as I mentioned, in a view model, we can easily inject a saved state handle instance since it's bound to a screen or set of screens where we have this saved state handle, in which we can then use to restore state from process death. But in a normal class, that is not possible. So you would need to have some ugly workarounds that in every view model where you use this global counter, you basically also restore the value if the user gets to this view model after process death. That is terrible, so don't do that. And on the other hand, if you make a singleton stateful and you only need that in one part of the app and not in all of your app, you always need to remember to reset the state manually when you don't need it anymore. So for example, you have some kind of shared dependency where you have the state whether the user is authenticated or not, so if they are logged in or not. And in your app, you have a section where the user is not logged in, where they simply can log in, and you have a section where they can only get when they are logged in. You use this shared dependency to just check if the user is currently logged in or not. When they log out at any place in your app, you always have to remember to update this state, since it's a singleton in the end. So even if you log out and they get back to the login screen, for example, the is logged in state in your shared dependency would still be set to true if you don't manually update that, since your singleton in the end doesn't have a real lifecycle. If you have a nested navigation graph, however, this can't happen because as soon as you pop the navigation graph, so for example, the logged in navigation graph, you have the actual behavior of your app. If you pop that from the backstack, then that means your state is automatically cleared and set to the default again, which is, hey, you're not logged in. So just be careful with that and don't use this approach, but I still wanted to put it in here because it is an approach that works, but which is not ideal. Let's get to way number 4, and that is very compose specific, which is called composition locals. I'm pretty sure you've all dealt with composition locals before if you've worked with compose, and these are specifically all these local something that current you use in your composables. So for example, the context can be retrieved with a local context that current, and it does not require us to pass this context down to all of our composables, like here in this my screen in our subcomposables, because this can be retrieved from any composable in the end. And we can create our own composition locals like this. For example, a local snack bar host state is a composition local of, and the default, if it's not provided, is a snack bar host state. So very often you, for example, have a scaffold in your app, which you just wrap around all your app content, around all your screens. So you just want to be able to show snack bars on every single screen. And normally what people would do is they would simply pass down the snack bar host to all subscreens so they can show snack bars. But you can also provide this with such a composition local. So here we use composition local provider, and this local snack bar host state provides this snack bar host state, which we just retrieve here. And we then pass it to our snack bar host. So from this point on, inside of this block, whenever we call local snack bar host state at current, we get exactly this state, which will refer to this default state here. So if we now launch this, take a look here, then we see a show snack bar button, and if we click that, we see a snack bar, even though our my screen from where we show the snack bar here, we don't even have this snack bar host state as a parameter, but rather from this composition local. So what is the advantage of this? That is, of course, it's very easy to share data between all your composables without passing them down to every single piece of composable. The disadvantage is that this only works for sharing data inside of composables and not inside of view models, for example. And you also have to be very careful with this because it can break previews and isolated UI testing. Because if you preview something where you don't have this composition local provider which provides something, then the preview won't know how to create this local composition and therefore won't show anything. So in this case, we can provide a default value, and this will always work in a preview. But in some cases where this state is retrieved from a composable function, which we can't call here. So for example, remember nav controller, This doesn't work because it's a composable function and we can't provide this as a default value. So in this case, we would need to throw an error that says simply no nav controller attached or so. We can still then attach a nav controller here in our composition by simply using remember nav controller here for this piece of code. But in a preview, we would always need to put this composition local provider around our preview composable then, because otherwise it would not know how to get this nav controller. And in this case, I would rather not do this and pass it down, or simply use callbacks to not need to pass down your nav controller at all. So composition locals are a good way to share data if it doesn't break the preview. And coming to the last way, which might be new to some of you, and that is persistent storage. So it's probably not a surprise to you that if we save something persistently, we can also kind of share that between different screens. But it might be new to you that we want to use this in some scenarios to share data between different screens and not necessarily really save something persistently. And here I want to give you a more real life example, and that is, let's say we have a session. So a session simply refers to the user information which is currently logged in, their token, and when this expires, for example. So very often, once you log in as a user, then you just want to be able to retrieve this currently logged in user from across the app. And what we can now do is we can create something like a session cache, where we can save a session, we can get the active session, so the session that is already saved, and we can clear it when we log out. And then the implementation of this simply uses shared preferences in this case, and then save the session serialized as a JSON with Moshi in this case. And while I won't go into the details of this class, this should probably be clear to most of you, unless you don't know about shared preferences, which is another video. We can now effectively take this session cache instance and inject it wherever we need it. So in our view models, for example. So this is very similar to the third approach I showed you by sharing a stateful dependency, just with the difference that now we don't have the actual state in the class, but persistently in preferences. So in contrast to way number 3, this now survives process death because we really save something on the disk. And especially for such a session, it's really important that it survives process death, because let's imagine the user is currently logged in and then they come back after process death to the screen where they are logged in, but then the session is cleared and in the app they are not considered logged in anymore, even though they are on a screen where they can only be when they are logged in, then this can really lead to bugs. The only thing you need to be careful with is the problem I also mentioned for the third approach, and that is that you of course need to clear the session when the user logs out, and in all screens where the user logs out. So I would personally just have one global logout function which clears this session cache, and whenever the user logs out from anywhere in the app, you just call this single function, so there's not much space for errors. So using such a persistent storage is just perfect for sharing global data which needs to survive process and application death. So I mean user initiated death. So if you have some kind of data in your app which is very frequently accessed from pretty much all your screens or a big part of your screens, then I would think about storing that persistently, like such a user session, for example. And just to show you that this works, here we have go to next screen, and when we click that, we just update the session cache here with the sample session, and we then display that on the next screen. Well, I think we display that in Logcat. Let's search for session. You can see here, I printed already. There is already a session because I tried this out before, and it's persistent storage, of course. But now whenever we go to the next screen, it will print this exact session. We can go back, it will print the session again. So sharing this, of course, works. So rather long video, but very important video, because this is something you need to do quite often. And I hope this more detailed video helped you. If it did, then you definitely also should check out my more advanced Android premium courses, which will prepare you to become an industry-ready Android developer. You will find all these using the first link in this video's description. And apart from that, I wish you an amazing rest of your week, and I'll see you back in the next video. Bye bye.